Today's topic is about relation schema, or we can say ERD mapping. In our last lecture, I discussed in detail about ERD, entities and attributes and relationships. There are three basic types of relationships: one to one, one to many, and many to many. There are three cardinalities of relationships. While making ERD schema, relation schema, or doing ERD mapping, we must have to look towards the cardinality. These are the few rules, five basic rules you should keep in mind while doing ERD mapping. First rule is, if the relationship between two entities is one to one. In binary relation means when the relationship is in two different entities, then two tables will be constructed. One table for entity 1 and second table for entity 2. In this case, primary key of any table can be the foreign key in another table. For example, the primary key of table 1 is A and the primary key of table 2 is B on attribute B, or we can say on the column B. One thing you should remember, when we talk about the table after ERD mapping, so we will call attribute as a column. So the primary key and foreign keys are on the column of the table, and columns show the attributes of the entity. So in this case, A column have the primary key in the table 1 and B column has a primary key in the table 2. So in this case, we can either make the A as a foreign key in table 2 or B as a foreign key in table 1. So we have two choices. Suppose we have student, and student is assigned a laptop, and there is a one-to-one relationship. So we can either select student ID as a foreign in laptop table, or laptop ID as a foreign key in the student table. Now if the relationship is one to many in a binary relation, then two tables will be constructed. In this case, primary key of the table with mandatory one cardinality will be selected as a foreign key in the table with the cardinality many, and vice versa. Vice versa for many to one. Relation can be one to many or many to one. The case is same. So the table which is on mandatory cardinality side, so the primary key of the attribute, the column which has a primary key will be selected as a column of the another table having the many cardinality, and we will put foreign key on that column on many cardinality side. If the relation is many to many in a binary relation, then three tables will be constructed. In this case, primary keys of both tables as from ERD or having many to many cardinalities will be selected as a foreign key in the third table. If the relation is not binary but it is ternary, so in ternary relationship will be converted to associative entity first before mapping, with mandatory one cardinality on all the three entities and many cardinalities with the associative entity side. And the fifth rule is that if the attribute in any table is multi-value, So for multi-value attributes, we will take another table and will join with the primary key with the main table. Let's solve some examples. This is the example. Here we have 5 entities: employee and car. There is a one-to-one relation. So this is rule 1. Here there is one-to-many relation in department and employee entities, and one-to-many relation in department and student entity, and student and courses entities are joined or related with many-to-many cardinality. So here 3 rules are covered: one-to-one, one-to-many, and many-to-many. So what we will do, the primary key of this can be taken as a foreign key in this core table. So first of all, 5 basic tables, the possible minimum table constructed will be 5, but here 5 table will be not constructed, 6 table will be constructed, because there is a many-to-many relation here. So third table will be constructed. So 3 and 3, 6 tables total. So here we can see the primary key is on EID. So EID can be considered as a foreign key attribute here, or registration number is a primary key attribute. So primary key attribute of car can also be considered as a foreign key attribute here. Similarly, the primary key attribute of department, which is DID, will be considered as a foreign key attribute or column in the employee table, and the primary key column, which is DID, will be considered as a foreign key column in the student table. And when third table is created from student and courses, which can be student courses table or student registration table, so the primary keys of both of these 2 tables, which is SID and CID, will be taken as a foreign key, and thus the third table will be linked to both of these 2 tables using primary and foreign key relations. This is the table constructed. I have only taken the primary and foreign key attribute. So this is the employee. You can see employee and student one-to-one. So I have taken employee ID, EID as a primary key attribute of employee, and department ID as a primary key attribute of the so this is a full table. Why we need to make it as a separate table? Because it is a multi-value. So if it because employee can have multiple phone numbers, so as it is stated in rules clearly that if the attribute is multi-value, so we will make it as a table, and the primary key of the main table will be the foreign key here. Here I forgot one more table, which is car. So you can draw a car table and make the car ID as a foreign in employee, or employee EID as a foreign here. The choice depends on you. Here we have DID as a foreign key here because of one-to-many relation here, one-to-many. Similarly, department ID will be a foreign key in the student table. Now you can see there are 2 tables with having many-to-many relation. So we will take another table, third table, which is student courses, and the primary keys of both the table are taken as a foreign key in this table. Let's see another example. Here you can see there is this is a publisher entity, this is a book, this is library branch, and this is borrower. The relationship between publisher and book is one to many. Book and library branch is many to many, and there is associative relationship, ternary relationship between these three entities. So this branch have one binary relation with the book and one ternary relationship which include book as well as borrower. So let's solve this example. First we will convert this ternary relation into associative. In our previous lecture I have explained in detail that what is associative entity. So this is associative entity which is producing association among these three entities. So borrows, this is associative entity, so it is in association with borrower, library branch and book, and the book have binary relation with branch also. This is many to many. So according to rule we will make library branch side mandatory one, book side mandatory one, and borrower side mandatory one, and all these relation as a many. To many can be optional or can be many one. So now convert the previous whole ERD into tables by mapping, applying mapping rule. So there is a one to many relationship. On publisher side there is a mandatory one. So on publisher table, in publisher table the primary key is on the column name, so this will be taken as a foreign key attribute or column here. Book and library branch have many to many relation, so new table is taken due to the many to many relation, and the branch ID and the book ID is taken as a foreign key or taken as a foreign key column here. So this is linked to both with these two foreign keys. Now you can see there is a mandatory cardinality on the borrower, library branch and book side, book entity side. So this means the primary key of book, library branch and borrower will be taken as a foreign here. So this is very simple. Card number is a prime attribute of the borrower, branch ID has a primary key and book ID has a primary key. So all these attribute will be taken here as a foreign key attributes, and thus the borrowers table will be linked to book, borrower and library branch. So this was all about the mapping. So the first step was to identify entities, then we finalize the attributes, and then we map this we specify the relations among the entities, and we will look if the relation is ternary, we will convert it to associative entity, and then by applying mapping rule as covered in this lecture, we convert it into relation schema. In next slide, in next lecture, I will discuss you about the functional dependencies, that how to identify these dependencies between the attributes and entities, and how to organize data into different tables and entities using normalization rules, first normal form, second normal form and third normal form. So it is discussed in our next lecture. Thank you so much for listening me. Thank you.